So for this project, I'm going to be working on silencing my server because it's officially spring. It's still getting down to a few degrees below zero outside right now, but as you might be able to tell, it's slightly warmed up in my server room. So my R710 is totally fine with its temperature. Fans don't spin up at all. But the Dl380 is known and does ramp up quite a bit, even though it's only about 20 degrees in here. If it gets above 15 degrees, it raises the fans up to this level, and so it's audible pretty much all over. And if I actually want to work in here, it's really quite shitty. And so as you can see, it's only about 20 degrees inside. It's actually a little below or a little above zero outside right now. This is still drawing air in, so it'd be even worse if that wasn't happening. So I saw a post. Let's just get out of here because it's, loud as shit. Like they're only at 70%, a few of them, but yeah. I saw a post on the HomeLab Reddit searching for this where someone used an Arduino to basically cut the PWM signal in half. And they actually have a threshold set. So I'm going to have links to that in the description below, but yeah, that's going to be the project for today. Or maybe a couple days. So I'm going to cut to the workbench now. Okay, so for the first step of this, I actually went ahead and already soldered the Arduino onto the breadboard here, just because that's simple enough. But I figured I would then actually show the construction of the low-pass filters. So that's basically 1 microfarad capacitor, 2K-ish resistor. So ground of the capacitor is going to ground. Then the positive of the capacitor is going into one of the analog inputs. And the resistor is also going to the analog input, and then the PWM signal input is going to the resistor. So that's going to be, just because fitting, all of these on here is going to be slightly annoying, I figured I would videotape it. Jesus, not a videotape. Although the quality, well, no, wait, 4K now. So I think basically the best option, based on the pictures, if you go look at that post that I'll have linked in the description for this, they basically did the same thing as this. And I was hoping for a slightly more elegant way of doing it. That would be a little less janky, and then give more room to have like the resistors mounted, like vertically. But yeah, just with the way this is spaced without designing a board for it, I don't think that's really going to work out all that well. And I could like design a board to do this, but I don't really think that's worth all the extra time and effort and expense. So I also need to cut, so I'm going to take these all out, and then I have to cut and get rid of the trace that's in between the two parts for this. So we'll start with the one on analog 0. So that'll just be so that'll be this bit right here. So actually, let's go ahead and you don't want to go so hard that you slip and get another one that you're not intending to get. Alright, so that's that one done. And we can go ahead and put analog zeros cap in. And we won't have anything conducting across there. So I'm going to go ahead and solder that right now, actually. Just so I can avoid making a mistake and having to redo a bunch of soldering and stuff. So yeah, I would like a little bit more room that way. Maybe I should have gotten a larger board. I also didn't want this thing to be massive though. So the resistors will just probably be soldered on this side of the board. And then we'll go ahead, trim those down, and toss that in the garbage. So then we have our first capacitor sitting nice and level, and a decent job on the bottom for soldering. So I am going to do the rest of these. So while I'm finishing up this last one, I just figured I'd mention, because I don't think I will have before, I would have probably used a Pro Mini since I have quite a few of those sitting around, and it has enough analog outputs, but I don't think it has enough PWM outputs. But the other factor is that this has, the micro USB header and the interface, like the programming interface like built into it. So you can program it off of just the USB header. So this means that I can A, use the internal motherboard header like in that post, even though that's not a huge, like a critical thing for me. But B, I can put the Arduino software on my server and actually, adjust this as needed, just on the server itself. So I don't need to pull this whole thing out, shut down my server, reprogram it. I can actually just, tweak the fan curve and upload the new sketch onto this while it's running. That might turn the fans off completely for a second, so maybe that still wouldn't be advisable. But it's just an option, right? So we got this one on here. Trim these off. And so now we have our board with the 6 filter capacitors, and then the soldering on the bottom with the cut traces so things aren't hooked together. So then the next step is to connect all of the grounds which I guess is actually just going across these top 6, right? Yeah, just going across that row of 6 there. So I'll see if we can do a solder bridge. If not, then I will go ahead and just use like a resistor lead for that. So there's 6 resistors. Now, I was thinking it would be kind of nice to repurpose these, but yeah, there's still ground going across there for the input. I would rather not have just a bunch of wires off the end. Okay. So yeah, I would kind of like to use like this section here for the inputs, but now there's the ground there, but I could also get rid of voltage in and pull that out. Then I have 2 there and the 4 inputs there. I basically just don't want a bunch of wires hanging off the bottom of the board, but that also might be one of the better ways to do it. Because yeah, unfortunately I can't really, like if I want to put one in there. I mean, I guess that kind of works. It's also sticking up super high, unless I go like that. But then I really doubt I can do that for more than one of these. Yeah, and there's going to be wires coming up the top and the bottom and all sorts of places like that. So it looks like we are going to be doing like a sort of messy setup on the bottom. So I guess we'll start with those 3 there. Do I want to have them coming off the side, or? Yeah, probably off the back side here. And this will sit in there like that or something. See, building your own circuit board for this would have been probably kind of nice. You could use SMD stuff and make this all really nice and tiny. Who will? Oh no, actually, I can go off of all of these. I don't need to go onto the capacitor. I can go onto this. So we will actually bend these at right angles. Right? Yeah. It's going to be a little ghetto, but... Oh yeah, but I have something else planned for this too. Different. Okay, so here I have all of the resistors set up on the bottom. And this is probably going to be slightly hard to show. But they're basically, doing the whole comb over each other onto those 6 pins. This one here is a touch-up. But yeah, so then basically I have all of those on the bottom, and I'm going to use some header pins. Because I not only have, just like a lot of the actual pins themselves, but I have these sockets. So if I can find these sockets. There we go. So I can actually make this whole thing detachable, because previously they had, they had wires going from these to just like, the same sort of thing, headers and sockets on the fan side, but I want to make the cables detachable as well. And then I can fine-tune the length of the cables, and also this will be, glued down and it'll be anchored on, so it'll be a more secure mounting thing. So we need 6. Okay, so I figure the way I'll do this is just with a female header on this side too. And then it'll just be a long connector, so the harness will be like one thing for all the fans. Yeah, not just 2 little quick things to plug in like that. If I had thought about that, I would have made this board longer. I wouldn't have cut it off so short. And then I would have been able to have that there. I could also stick it there. Yeah, actually. So this is pins 1 through 6, so I could hot glue the other side onto here and do 1 through 6 on the left, and then just run wires. I quite like that, actually. That'll be closer to my original plan. Okay, so It really does piss me off that these came apart when I was stripping the wires. However, it's not something I'm going to see all that often. And it's still pretty close, you know? It's not amazing. And I do want to redo it, but it's also just a lot of work. And I don't feel like doing that when there's a bunch of other stuff to do for this. So yeah, this is basically this done. So you can put your inputs onto the bottom here, and then you can put your outputs from the PWM onto there, which are coming off of the digital pins that correspond to them. Yeah, it's definitely annoying, but yeah, it's just not worth the effort for that right now. If I wasn't so tired, maybe, but I have another project that I was also just working on that's had stuff not work on it, and I'm dealing with that too still, so that's still a nice little splash of color onto this project and a little retro touch. So I'm going to hot glue these to keep them in place, but then the next part is going to be on the actual server itself. Alright, so with this basically finished and it's actually programmed, first I realized that these actually are inverse of each other, but I just keyed pin 8 on the top, or pin 1 on the top and pin 8 on the bottom, and just so I put them in the same spot. And now the one that I saw where they had done this, again that'll be linked in the description, they had put the Arduino up here and had the wires going out all over the top. I want this to be a little more integrated and a little less janky looking. So there's actually a spot in here, and if I ended up putting a second drive cage in that's on this side, that's not going to change the width or size of anything in here. This little spot is basically just all hollow and just has the status light indicators and stuff on there. So I can unplug this basically front panel I/O, essentially, and undo this screw, and I should be able to pull this section out. And I can actually go ahead and mount the Arduino, just, you know, sort of in there, and have the wiring come out along the front here. So I'll probably have to, just looking at the construction of this, pull all of these out, and just like cut off that corner essentially on each side, just to, you know, have the wires come out the front. And then I think it's just the green wire on this connector that you need to actually splice. Might be the yellow one. But yeah, then all the wiring will come out from the front here, and I'll have it all the right length to meet up in a connector and plug into there. So yeah, that should be pretty good. Unfortunately, I don't think that I have a USB cable, a mini USB cable that will go from there to there without a shitload of slack. I'm talking like feet. I'll have a look, but unfortunately I don't think I'm going to be able to finish this off tonight, sadly. Alright, yeah, so this front section just totally comes out. And there's just loads of room in there wasted. It's kind of like that section in there for the R710 that was like a swappable hard drive thing, or tape drive, from what I understand. Although I think it was actually just like a hard drive, but they called it a tape sort of backup thing. You could put a Raspberry Pi in there and like a little screen. I think that would be fun. But yeah, loads of room in there. The Arduino can sit in, you know, wherever, and then the cable can run from the USB header there. Presumably it does data as well, not just power. That would be stupid if it didn't. And then yeah, then the Arduino can sit here and all the fan controls can come out the back. But yeah, this is gonna have to wait till I can go buy a different cable. Okay, so now I have the frame which holds the fans. They just, you know, click in. Removed. Just 6 screws with vibration isolating mounts. And so I'm going to show you how to modify these fans. Now, I already started on this and it didn't record, so here's one I prepared earlier. We'll get more into that. But the reason I have this whole thing out is because I think I'm going to have to cut out these these like sides a bit, just so it fits a bit easier. So I'll go ahead and show you, basically, because it is a relatively snug fit. And I'm not going to be hot swapping these a whole bunch, but I'd rather not have the cables get, you know, messed around too much. So you can just sort of do it like that, which I'm not a huge fan of. And it also makes the fan actually quite difficult to remove, and you can see it pinches the cables. But if you put it underneath, then it goes in easy to start, and then I could just tuck it into there. So that's why I took the whole thing out. But yeah, so essentially what you see here is the PWM wire spliced out. And so I was debating whether to do male or female. I went for female just because it can't short out against anything. But the good thing also about doing connectors like this is that you can make little, just like jumpers with 2-pin males. And so if you want to remove the Arduino completely, then you could just put a jumper in, and that just jumps the PWM wire back, so the motherboard has regular control of the fan with just a drop-in thing like that. You know, if you're selling your server or this doesn't end up working, that'll be the case. So I'll show you how to do this. One thing to note, I guess ahead of time, is that these two sides are different. So basically this plastic part has wider cutouts than this one here. That stumbled me for a little bit. And this would be a good chance to clean these out nicely. As you can see, they're quite dirty. My air compressor chuck is gone, so I'll have to find that. But yeah, essentially you just unclip one of these sides, whichever comes off easier, and then unhook it from there. And actually you don't need to do it on this side. So you can keep these off to the side. Probably good to actually keep them in like a roughly organized order. And so here we have the fan connections, and the green wire is the PWM wire that we want to deal with. So we can actually angle this backwards and it popped out of there. Boy, these really do need cleaning. So we will then cut the PWM wire. Slightly nerve-wracking the first time, because I don't have any spares. And so now this is that kind of wire that has like a somewhat gooey feeling installation on it, so it's easy to overdo the amount of pressure that you use with your side cutters. And then basically just strip, but also take off the wire that you're trying to use. So just be a little cautious with it, especially because there's so little to work with. And because there's so little to work with, I'm not going to be twisting the wires together that I'm adding in. These are actually going to remain just as they are like this, and I'm just going to solder them together, whatever style you'd call it. Just, tin both sides, let the solder join them. It's not a high current connection or anything that's going to be under a lot of stress or strain, so I'll then take some wire. It's probably too long. One other thing, the heat shrink tubing I have is just a little bit too big for this. So I'm actually just going to be using electrical tape to insulate these. That's really not how I like to do things. But it's 2 a.m., everything is closed, and I don't feel like putting this project off for yet another day. It has been a few days since the last bit of this video, just because work has been hell and I have been super busy. Doesn't mean I get paid more, just means I get to work more. Alright. We don't want those too long. So I'm using the brown to indicate, right, so the motherboard uses a 3.3 volt PWM signal, and the Arduino is sending a 5 volt. So we're sending the motherboard connection into those low pass filters on the Arduino that go into the analog pins. And we're controlling the fan with a 5 volt PWM signal. That doesn't affect how it runs or anything, but basically you don't want to send the 5 volt PWM signal to the motherboard because that could cause some problems. I don't know for sure. I'm not going to experiment and find out. So I'm basically using red to indicate 5 volts, brown to indicate, the 3.3 volts, the lower voltage signal. And then I just used some wire from a ribbon cable. I just took those two wires off of it, a length of them, because I wanted it all to be the same, so it's easy to remember. And there's a decent amount of room inside this when it's put together, but you don't want to go overboard with your electrical taping. Alright, so then it's good to have another fan just that's assembled as reference. Actually, I'll do the one that I've already done. So we can see that this is going to be at the bottom, and this connector is going to be here. And so the reason for doing this versus just putting other fans in is that A, it's cheaper to do this Arduino instead of buying 6 Noctua fans that have similar-ish airflows. It's going to see the RPM signal that it wants, but basically it actually doesn't really get a feedback, but it also has a rotor lock signal, which I think is the yellow wire on this, which is a rotor lock, so that if the actual motor freezes up, then it gets a signal, and then you get an alert through integrated lights out. And that's functionality that I wanted to keep. I really do wish I had my air compressor chuck. Just based on how dirty these are. Holy crap. Alright, so we have the smaller ones to one side. Put that together. And put this together. And then we need our wires to come actually the other way. So you can see there's a little bit of room for stuff to move around in here. And I'm just having them come out that corner there, basically. So then, I will just get these to similar length. And then I will tin these. And I don't want that to be crazy long. I'm also going to get a couple pieces of heat shrink while I remember. And then we'll prepare our female header pin. So you basically want to cut on the one past what you need, so we need 2 lengths, so I cut on the 3rd. Alright, that's pretty good. So then we will go ahead. And I was thinking of getting like keyed connectors for these, but I figured the wire color and also some like silver Sharpie on them, like I did on the Arduino itself, will probably be enough for keeping it organized. And just be extra careful. That way I don't... I mean, maybe the board could handle the 5.5 volt PWM signal feeding back into it, but I'm not going to be trying that. Don't have the money to play those kind of games. Alright, so then we'll slide those up. Give it a little bit of heat. And there we go, another connector finish up, basically coming out of the fan. So now that we got a couple of those, I'm not going to do them all on the video just because it's going to take up a lot of space on my phone and whatnot. And you also don't need to see it all fast forwarded. So I'm just going to go ahead and make sure I have this the right way around. So the fan connectors plug in on the right. So like that. So then I'm going to, because I'm going to be mounting my Arduino in the front of the server. It's surprisingly thick plastic. A Dremel might have been a better choice for this. Okay, that ended up cutting quite smoothly though. So then you can see we just have the one corner notched out. And then when you insert your fan, you tuck that underneath. And it should click in and not have too much strain on it. So let's, oh, I put that in upside down. So that's something else for you to look out for if you're doing that yourself. Have these on the right way. So yeah, previously these were getting really pinched, just like along the side. So I'm hoping now it's going to be less so. Probably still not great, but they're probably not going to come in and out as often. Just wondering if I want to bite into it a little more or something. So that is locked in though. Does the left side on those lock in usually? Oh, maybe not on these end ones, because... Oh no, actually it doesn't have a tag. Alright, so that's locked in normally, and it's not very difficult to pull out. Previously it was really difficult because of the friction of this connector in the side, but now it actually comes out really nice and easily. I still wouldn't do it a load. It's still getting a little bit pinched, but that shouldn't be anything too bad. And we can just go ahead and cut into this a little more. Just make some more room. This should be a relatively cheap part of the chassis if you mess it up, so. It's not super pretty, I know that much. Definitely not super pretty. But now if we go ahead and insert our fan with that at the bottom. Oh, excellent. So that's got some slack basically now. That can move in and out. Those wires aren't getting pinched in and out at all. And so I'll just show you from this side how much I've cut in versus a normal one. And then maybe a bit closer in case that was out of focus. You basically have the wire underneath the fan. Clicks in. And I mean, depending on the position. Got some slack. No pressure pulling on that. So I'm just going to basically do the rest of these fans and notch out the rest of these and then put them in the server. Actually, maybe I'll work on the wiring harness first while they're in this all at once, and then I'll put everything in the server. So we'll cut to when I have another stage ready to go. Okay, so that is the last of these fans done. Oh, hang on. Almost. Oh no, wait. So we've got one. Ah, there we go. And we've got 2, or I guess 5 and 6. Really. So they're not all super the same length, but that's pretty good. And so it's basically going to sit like this, and then the Arduino is going to be somewhere about here, I think. So I'm going to be generous with the length, but yeah, essentially I'm going to start. Now one thing I don't know if I mentioned in the previous part, I actually should have flipped this because it's inverse. So this is 1 through 8 here, right? Yeah. So outputs 1 through 8, inputs 1 through 8. So I'll have to remember that just, 1 to 8 from this one, 8, and then 1 to 8 on that one. So, yeah, aside from that, basically just need, and I'm going to be using just some red and black spools of wire. This is unfortunately going to be a little tricky just based on how much stuff there is around here. Oh yeah, and I also need a bunch of mail headers. Alright, so now this is officially ready for installation. I might just cut to it partially installed. I might set up a tripod in the room. We'll see how the mood strikes me. But yeah, as you can see, we have a fully disconnectable harness that you can unplug both ends of. And then we'll be able to just pop that back in there. They don't have a huge amount of friction holding these in, which isn't great, but as long as there's not any stress on it after you've installed it, like as long as it's fairly loose. I don't see these backing out being a big issue. And if you're concerned about it, you could just put some hot glue on the connectors themselves. Or, you know, tape or something. Alright, so I figured it's a little boring if I don't actually show it being put in. So yeah, basically that's actually looping around a little much, but yeah, we're going to go ahead and put this bad boy back together. So I'm actually going to pull this out and hot glue the Arduino in there, and then basically I'll have this, oops, where is it? I have, yes, this white USB cable, which is going to go from the Arduino, and that's going to be sitting in there, to the motherboard USB header there. And man, that is a USB connection that has not been used ever. That is super friction. I really like that. But first is getting the actual fan part of the chassis back in, I guess, whatever you would call it. And yeah, so with these modification slots, they pop in and out really nice and easily. And I just have my pile of parts stuck on top of my pull-out display. Nice little IBM retro unit that I added a KVM sort of into. Okay, so different angle again. And yeah, we're going to be going for semi-permanent instead of permanent. Not 100% hot swappable, or at least as easily, but you know. I'd much rather have these slightly harder to take apart, but not coming undone randomly. Here goes nothing. Okay, so the Arduino's on, the fan spun up and span down, and if I have a look, they're all spinning, so I'm going to turn this off. So it's sitting at a bit of an angle, but it's got the hot glue on the side there, so any metal it touches will be insulated from. So that's still a little janky. But if I go ahead and take this off there, oop, let's lock the exposure. And you can see we have our wiring harness set up, all connected, and wrong way, our Arduino tucked down in there with the USB cable going to that header. Hopefully that didn't nauseate the shit out of you. This gimbal isn't amazing to use. So then we can put our PCI riser back in. I do quite like the R710 for not having a PCI riser like this. Although this was easier to mess around when I was trying to put a GPU in this thing. I'd still kind of like to do that, but... Well, I guess now with the fans quiet, now that I can control them better, that should be easier. But yeah, now we just go ahead, slot it back in, and the next bit you should see should be Hopefully the server nice and quiet, maybe some screen capture stuff. Okay, so if we log into integrated lights out here, this degraded thing is normal. That's because some of the hard drives I have don't play nice with HP's monitoring. So it thinks some of them are overheated. Yeah, they're not. But if we go ahead and look, fan speed 55%. And if we go ahead and check our serial monitor, we should be getting, yeah, there we go. So apparently this cuts off at 50% is what he was saying in the post. So if it wants 50%, then it's going to not do that. And he said to change the intervals. So I don't know for sure if he means these correction factors, but I'm thinking maybe this. So this is going to cause my fans to stop spinning briefly, I think. But if I set that to 70% as a threshold, hopefully. See, the problem is, it goes up to like 72% immediately. Yeah, 73%. So if I set it to like 80%, then we'll try and upload. And we'll hope shit doesn't hit the fan. I'm not at the server right now, I'm just on my laptop doing this because it's unbearably loud in there. Board, Arduino Nano, oh, old bootloader. Okay, we'll upload this. Okay. So let's see. So it's requesting 78%. So apparently it's running it at 58%. So I think what I'll do is I'll set it back to where it was, and I'll set the camera up in there, and then we'll see if there's a difference when I upload the sketch. So you should notice it drop the speed down. But yeah, so it should be dropping, 15 to 20% off the speed of the fans. And oh yeah, wow, my door is open, and if I just take one of the sides of my headphones off, it's an amazing difference. But if we go ahead and set it back to, so this was this PWM, this line here, if PWM is between these amounts. So if we set that back up to 50% and upload, I'm going to listen out. So the fans immediately go back up. And I can totally hear them now. But before I couldn't. That's fucking incredible. Okay, I'm going to set my phone up as a camera in there. Actually, I realized why bother setting my phone and doing like split screen stuff when I can just show you this screen here. So yeah, this is what it's normally like. So I'll make it so that you can hopefully, hang on, see that. So we'll change this back to an 80%, and we'll upload, and I'll be quiet. So that's pretty different. I'm just wondering if I want to go to 90%, if that'll make it even quieter. Let's see. Maybe I should have done screen capture at the same time for this anyways. So I mean, that's already like way quieter. It's not as quiet as it could be though, because it's still running these at 50-some%. So I think what I'll have to do is play around with these numbers here. So I'm not quite sure what that correlates to. That's going to need some experimenting. But already as it is, I mean, we'll set it back to the 50% again. And then we'll go back up to 80% where it'll actually work with my server normally operating. Not sure why it's not doing fan number 5. Unless that one is maybe like the connector backed out slightly or something. I noticed when I was testing though, it seemed to not do fan number 5 for some reason. Yeah. Double correction factor. So maybe this is like the... This is what it is for each of these. So minimum fan speed probably, and then correction factor. So, oh hey, you know what? 50, comma. I think there was a mistake in the sketch he uploaded, so let's upload that and see if that fifth fan knocks down again. Yeah, there we go. Now fan 5 is working. So there was a mistake in the sketch he uploaded that I found. That's kind of fun. So now what I should be able to do is say just like 20% on all of these. Let's do like 25% on the middle two, because they generally run hotter. Let's do like 22%. Let's not go too crazy. And of course, playing around with this, you're going to have to really watch temperatures for a while, I think. Although if it does detect a problem, it should just ramp up to 100% and not have an issue. So don't take my word for that, though. That one's doing 65% difference. Oh, that's 20.0 instead of 0.20. That's why. There we go. So that's nailing 20% difference, but now they're running at, you know, like 60% speed, which is still pretty good. Not door open good. So let's go ahead and say like 25% on the edges. So this is actually easier to change than I thought. That's quite good. So I'm going to pull up HW info. Hang on. Okay, so we have HW info here. So let's find our temperatures. 29 degrees and whatnot. So let's go ahead and set this back to 50% and see what our temperatures are at, and then move it back up. And I'm sorry about like the screen glare and stuff. So on the main, actually on the second processor, we're getting higher temps. And so according to this, then we should see just like the full speeds. Where are they? Oh yeah, those are all the system temperatures. There we go, and fans 78%. But if we go ahead and set this back up to the 80% correction factor, you'll see that our system reading for the fans doesn't change. And if we go back up to our core temperatures, that's really hard to see, but yeah, I mean, they're not really changing a whole lot, which is just goes to show, like, the room's only 20-some degrees in here. So let's just say, oh, see, it did ramp up still a little bit there. So they're still running at 50-some%. So I want to say, let's try and make it super silent. So we're going 30% on the 4 side fans, and 25% on the CPU fans. See, I mean, already that's like way quieter. It's still nailing that drop off. I might see if I want to go further. I don't know. But like, I'll just pick the camera up, and you'll see compared to the start of the video. Even, actually, yeah. Let's go ahead and turn the big central fan thing back on. Sorry, I just gotta plug it back in. Oh, you know what? Oh, there's the cord. So let's go ahead and plug in the roof fan still. Even with that roof fan on, it's way quieter. And if I go ahead and just turn off the one on the roof of the server rack, even with the door open, way more tolerable. Maybe I should turn that light on so it's interesting for you. Way quieter. And with the door closed, you can still hear it, but it's not nearly as bad. That's fucking fantastic. That's great. This was worth every single second I spent on the project, even as it is. Even if I'm not going to get them down to like 20% safely. Yeah. That's just fantastic. So I hope you enjoyed this video. If you have an HP server, Dl380 G6, G7, possibly G8s, I don't know. I highly recommend this. This is amazing. This is so good. I wish I'd done this like years ago, but I only found it like maybe 7 or 8 months ago, and I finally got around to doing it. This is so worth it. Alright. Peace out. See, there's the thing. I just closed the server room door just out of habit. But really, I mean, I can leave that open, and it's still not nearly as bad as it was with the server room door closed. It's going to be a hard habit to break. So, just another little quick bit on this. I went for a slightly more balanced, 35% on the edges and 28% on the middle two, and that's still pretty quiet. It could be quieter, but the CPU temperatures were getting a bit higher than I wanted. I think on this CPU I need to redo the thermal paste, or that's the one with all the hard drives in front of it. But as you can see, I'm actually rendering a section of this video, Inception, right now, and the room temperature is still, 20 degrees or so, and even with these fans spinning at about half, we're only getting 50 degrees on CPU. So yeah, that's with like 99% load on all of it. If I pull it up here, or 95% on all cores on both processors. Yeah, still takes ages to render these videos, and this one's going to be a nightmare because there's so many sections I need to fast forward that I need to render twice. But anyways, yeah, with those fan settings, 50-some degrees under 100% load in a 20-degree room is what you can expect. Just a third level of inception for something else I remembered that's important. The HP servers actually use an inverse, like an inverted PWM signal. So that means that 0 volts is 100% fan speed, and that's what those fans use. So when you actually upload a sketch to the Arduino, you heard the fans spinning up like 100%. That's because the Arduino is cutting off the output on the PWM pins. So if your Arduino fails, basically, your fans aren't going to be dead, and when you upload a sketch, they don't die. Instead, in those situations, they're going to go up to 100%. So it's a safe failure mode. So I just wanted to add that in for anyone who might have been worried about this sort of project. Just a third level of inception for something else I remembered that's important. The HP servers actually use an inverse, like an inverted PWM signal. So that means that 0 volts is 100% fan speed, and that's what those fans use. So when you actually upload a sketch to the Arduino, you heard the fans spinning up like 100%. That's because the Arduino is cutting off the output on the PWM pins. So if your Arduino fails, basically, your fans aren't going to be dead, and when you upload a sketch, they don't die. Instead, in those situations, they're going to go up to 100%. So it's a safe failure mode. So I just wanted to add that in for anyone who might have been worried about this sort of project.